In this video, we'll look at how to solve equations with squares and square roots. Squares and square roots are inverse operation. One type of the problem can be a variable to the second power equal a number. This question means what number times itself equals 25? Knowing that square means a number multiplied by itself, the question is what times itself equals 25? 5 times 5 equals 25. So the x value must equal 5. Why? Because 5 times 5 equals 25. We'll look at a few more examples and see how to use inverse operations and how to use positives and negatives as well. So for solving equations, we use inverse operations and we find the value of the variable that makes the equation true. Square and square root are inverse operations. So when we have second power, it means the number multiplied times itself, and then square root is asking which number was multiplied by itself. So, for example, when we say 3 times 3, a number multiplied by itself, we call it 3 squared. 3 squared is 9. So 3 times 3 is 3 squared, and that equals 9. Well, the inverse operation will be the square root of 9. So if I inverse that thought process, I have square root of 9 equals square root of 3 squared. And here is when we're going to use the inverse operation, where square and square root cancel each other. So therefore, square root of 9 equals 3. So 3 times 3 is 3 squared. The answer is 9. Inverse that, square root of 9 equals square root of 3 squared. Square root and square are inverse operations. They cancel each other. The answer is 3. Let's see another example for the pattern. Multiplying a number times itself. Times 5. 5 times 5 means 5 squared. 5 squared is 25 because 5 times 5 is 25. Inverse that. Square root of 25 is square root of 5 squared, which is the 25. Square root and square are inverse operations. The answer is 5. Square root of 25 is 5. Same relationship works for variables. A number times itself is called number squared. Inverse of that will be square root of square number, where the square root and square are inverse operation. So the square root of x squared equals x. When we're multiplying the number by itself, whether it's positive times positive, the answer is positive, or negative times negative. So positive times positive, the answer is positive, or negative times negative, the answer is still positive. So when we're multiplying the number times itself, the square of the number is always positive. For example, if 4 times 4 are positive times positive equals 16, and negative 4 times negative 4, a number multiplied by itself, negative times negative is still positive, 16. Therefore, for the square root of 16, we can have two possible answers. 4, square root of 16 is 4, because 4 times 4 is 16, and we can have square root of 16 equal negative 4, because negative 4 times negative 4 is still 16. So the square root of a positive number can have two values, a positive number and a negative number, because positive times positive is positive, and a number by itself, such as negative times negative, is still positive. Let's see another example. 1 times 1, number times itself, is positive 1. Negative 1 times negative 1, number times itself, is still positive 1. So 1 times 1 is 1, and negative 1 times negative 1 is 1. Therefore, inverse operation, square root of 1 has two possible values. A 1, because 1 times 1 is 1, and and negative 1, because negative 1 times negative 1 is 1. So square root of a positive number can have two values, positive and negative, because positive times positive is positive, and the number times itself, such as negative times negative, is positive as well. Next, we'll look at a few examples. I'm going to show 3 examples. If you can pause the video and draw the chart first. I'm going to have the problem, the meaning of the problem, how to use inverse operations to solve, and then how to check your answer. So for example, I have 16 equals x squared. The question is asking, what number times itself? Squared means what value times itself equals 16. So if I'm asking that question, I'm thinking, what number times itself equals 16? Then I think 4 times 4 equals 16. 4 times 4 equals 16. So my x value must be a 4. How to use inverse operation to solve? I am going to use square root on both sides. Square root of 16 and square root of x squared. So 16 equals x squared. To use inverse operation, I'm using the square root of both sides. So I'm using the inverse operation. Square root of 16 equals square root of x squared. Square root of 16 equals 4. Square root and square are inverse operation. X equals 4. Then we said a number times itself equals 16, such as 4 times 4, and a number times itself, negative 4 times negative 4, will be positive 16 as well. So this equation can have 2 possible answers: 4 positive or negative 4. Why? Because in the check column, I'm going to say 4 times 4 equals 16, and negative 4 times negative 4 equals 16. So my x value can have 2 possible answers: 4 times 4, which is 16, so the x value can be 4, or negative 4 times negative 4 is 16. That's why my second x value is negative 4. Let's say I have another example, number 2, which is going to be 81 equals y squared. First of all, what does this question mean? This question means y times y means what number times itself equals 81. So understanding the square, what number times itself equals 81? So you think 9 times 9 equals 81. Therefore, your y value must be 9. Why? Because 9 times 9 equals 81. If I substitute in the original equation, 9 squared equals 81. How do you use the inverse operations? Inverse operation of square is square root. So we're using inverse operation, square root on both sides. That means square root of 81 equals square root of y squared. The original equation and inverse operation, square root on both sides. Then we simplify. Square root of 81 is a perfect square that equals 9. Square and square root are inverse operations. They cancel each other. That's the value of y, equal 9. When we check, 9 times 9 equals 81, but then negative 9 times negative 9 equals 81 as well. So we add to our answer that this equation can have two possible values, 9 and negative 9. So the y value can be 9 or negative 9. Let's see another example. Let's say t squared equals 4. The meaning of the question is, when we say squared, it means number times itself. In other words, this question means what times what number times itself equals 4. 2 times 2 equals 4. Therefore, the t value has to be 2. Why? Because 2 times 2 equals 4. So if I substitute this value in the original equation, t is 2. 2 to the second power means 2 times 2, which equals 4. How to use inverse operations? Inverse operation of square is square root. So I'm going to use square root on both sides. Square root of the original equation on both sides. So square root of t squared and square root of 4. Square root and square inverse operations bring down the value of t, and square root of 4 is a perfect square equal 2. So the t value must equal 2. Why? Because 2 times 2 equals 4. But then a negative value times another negative value of the same kind, negative times negative, negative 2 times negative 2, will still be 4. So therefore we need to add the second possibility. The t can be 2, or the t value can be negative 2, because by being replaced in the original equation, negative 2 squared will be negative 2 times negative 2, which will be still positive 4. So both of those values, by being replaced in the original equation, make a true statement. And that is what we do when we solve equations. When we solve equations, we use inverse operations, and we find the value that makes the equation true. So in the square equations, we have two possible values that make the equation true.